Numerical series 4. The volume and temperature of air assumed to be an ideal gas in a closed vessel is 2.87 meter cube and 300 Kelvin respectively. The gauge pressure indicated by a manometer fitted to the wall of the vessel is 0.5 bar. If the gas constant of air is R equal to 287 joule per kg Kelvin and the atmospheric pressure is 1 bar, the mass of air in the vessel is. So the options are 1.67, 3.33, 5.00, 6.66. So before we solve the numerical, let's identify the data given in the question. So here it is mentioned that the volume and temperature of air in a closed vessel is 2.87 meter cube and 300 Kelvin respectively. So here we consider the volume to be V equal to 2.87 meter cube and temperature of air within the closed vessel is 300 Kelvin as per the question. Let's consider a closed vessel here. This closed vessel contains air as an ideal gas. Now here in the question mentioned that a manometer is fitted to the wall of the vessel. So this is the wall of the vessel. So to this wall of the vessel, a manometer is fitted which reads the gauge pressure that is equal to 0.5 bar. So here let us consider P gauge that is equal to 0.5 bar. So next data is given, that is the gas constant of air, and that is equal to 287 joule per kg Kelvin. So let's write down the R equal to 287 joule per kg Kelvin. Next data is given, the atmospheric pressure is 1 bar. So here we consider PATM equal to 1 bar. Now the question arises that what we are going to calculate for the given question. So it is mentioned that the mass of air. So here we are going to calculate the mass of air and that in kg. So here we consider mass of air, that is M. So this we have to find out. Now which approach we will be using here? So let us consider the ideal gas equation. So why we consider this ideal gas equation? Because here it is mentioned that assume air to be an ideal gas. So that's why we consider ideal gas equation. So that is PV equal to mRT. So if we observe this expression, so here we have volume V, gas constant R, temperature T, and pressure is also mentioned here, that is in form of gauge pressure and atmospheric pressure. Now the point of confusion here arises that which pressure is this? So this pressure is neither gauge pressure nor atmospheric pressure, but this pressure is absolute pressure, and we know the relation between absolute pressure, gauge pressure and atmospheric pressure. So the P absolute is equal to P atmospheric pressure plus P gauge. And we know that the gauge pressure is a pressure which is measured above atmospheric pressure. So now I think there is no confusion which pressure we have to consider here for the given question. So here we have to consider the absolute pressure, and this absolute pressure is just the summation of atmospheric pressure and the gauge pressure. So here we consider PATM, that is equal to 1 bar plus P gauge, that is 0.5 bar. So that is equal to 1.5 bar. So this is the magnitude of P absolute. So this P absolute we have to substitute in this ideal gas equation. So if we rearrange this ideal gas equation, so we have M equal to P. So here we consider to be P absolute into V by R into T. So here we substitute the magnitude of P absolute, that is 1.5 bar, V equal to 2.87 meter cube, R equal to 287 joule per kg Kelvin, and temperature T is equal to 300 Kelvin. But before substituting all this magnitude in this equation, in this ideal gas equation, we have to make all the unit, or we have to convert all the unit in the same manner. So for that, we consider this P absolute to be 150 kilopascal. So 1.5 bar equal to 150 kilopascal. And the value of R, it is given 287 joule per kg Kelvin. So convert this into kilojoule per kg Kelvin. So that is equal to 0.287 kilojoule per kg Kelvin. So now we substitute all this value here. So in place of P absolute, we substitute 150 into volume is given 2.87, R is given 0.287. After unit conversion, it becomes 0.287 into, that is T is 300 Kelvin. So this is the magnitude of all these parameters which we substitute here in this equation. So after solving this expression, we get M is equal to 5 kg. It means now we can see that option C is the right answer for the given question. Thanks for watching. See you in the next video.